Now step number 5, that is design of section for hoop action. So design of section for hoop action. We got the maximum hoop tension, that is of maximum hoop tension, and that is equals to 119.17 kilonewton from the earlier step, and it was actually at the distance of 2.4 meter from the top, or from the base. 4 minus 2.4, that is 1.6 meter from the base. So now we can calculate the area of reinforcement. So therefore we can write down area of reinforcement for the hoop steel, and that is equals to area equals to simply force divided by stress, or stress equals to force divided by area. From there you can calculate area equals to force divided by stress. So maximum hook tension divided by sigma st, which we have seen in the earlier step, and so therefore which is equals to now maximum hook tension, that is 119.17, will convert in terms of Newton and divide by 115. So kilonewton we have converted into Newton, and if we just calculate this, you will get it around 1040 mm square. So this is the area of the ring, or area of the hoop reinforcement. Now this hoop reinforcement is to be provided on both the faces, and therefore we can say area of the reinforcement on each face, that would be half of this total area. You can mark it as AST hoop. So therefore this is on both the face. So AST hoop on one face, and that is equals to 1040 divided by 2. So this is going to be 520 mm square. So we got the area. So we need to choose the diameter of the bar and just calculate the spacing. So in this step we have already calculated the we already have the calculated maximum hook tension. So from that we have calculated the area of the reinforcement. They are called as the area of the hoop reinforcement. Then once you calculate the area of the hoop reinforcement, which is to be on the each face, so now you need to calculate the spacing. So therefore you can use 12 mm diameter. Now this hoop reinforcement is actually the ring, in terms of ring, and area of 1 bar, which we already calculated in the earlier step for 12 mm. We got it here, 113 mm square. So you can write down 113 mm square. So now we can write down, therefore spacing would be equals to spacing would be equals to area of 1 bar divided by AST hoop, and this is multiplied by 1000. So area of 1 bar, that is 113. You got this total area of 520 multiplied by 1000. So you will get it the spacing of around 217 mm. You can round it down to 200 mm. So we can write down, providing 12 mm diameter rings diameter rings at 200 mm center to center. Okay, this is to be provided on each face, so you can write down on each face. So this is how you can calculate the hoop reinforcement, which is actually at one distance, and that distance is up to distance of, as I said, this maximum hoop tension, which is actually 2.4 meter from the top. So from the base we can consider 4 minus 2.4, which is equals to 1.6 meter. Now you need to calculate the reinforcement above that. So let us calculate the maximum hoop tension at 2 meter below the top. So hoop reinforcement at 2 meter below top. So this is what we need to calculate now. So before that, we have calculated the maximum hoop tension, which is at the 119.17, that is from the top, 2.4 meter from the top. Now you know that the hoop tension. So hoop tension, formula for the hoop tension, which is equals to WHD by 2. So W, it is 9.81 into 10 raised to the power 3. H you got 2 meter, and D is 10 divided by 2. So if you just calculate this value now, so you will get it around 98.1 kilonewton. So again you need to calculate the area of hoop reinforcement as we have calculated in the earlier step. So therefore you can write down AST hoop 1, and that is equals to hoop tension divided by sigma st. So 98.1 into 10 raised to the power 3 divided by 115. So if you just calculate this, you will get it around 855 mm square. So you got this 855 mm square, and this is on both the face. So therefore area on each face is equals to 855 divided by 2, which is around 430 mm square. So again you need to calculate the spacing. So how to calculate spacing? Just like in the above step. So therefore spacing will be equals to, we are going to use the same 12 mm diameter ring. So Fi divided by AST multiplied by 1000. So this is 113 divided by 430 multiplied by 1000. So you will get it around 260 mm. So here you can write down. Earlier we got it here 200 mm. Now we got it here 260 mm. So we can even make it 250. So providing 12 mm rings at 250 mm center to center on each face. Similarly, we can calculate the hoop tension at the top 1 meter. So if you have already calculated the earlier one, so next what we need to calculate, so AST at top, and which is to be provided minimum AST. So AST minimum I can write down here, which is equals to, this is of 0.3% of the thickness multiplied by 1000, and you got it here 0.3 multiplied by 160 multiplied by 1000. So this is out. So this is coming out to be around 480 mm square. So 480 mm square you got. Now what you need to do, you just need to calculate. This is on both the face. So therefore AST minimum, which is equals to 480 divided by 2, that is 240 mm square on each face. You got it here, on each face. And we can calculate now, therefore spacing as that of the earlier. This is equals to area of 1 bar divided by total area multiplied by 1000. So this is 240 divided by, so this is, sorry, actually 113 divided by 240 and multiplied by 1000. So this is coming out to be around 470 mm. So therefore you can write down, therefore providing 12 mm fire rings at 460 mm center to center at top portion. In the next video we will go through the distribution reinforcement and the other steps. Thank you.